Hello and welcome to our last lesson on the nutrition unit. We're going to learn about enzymes. So again, this is the last lesson. There's two lessons to enzymes. One of them is the notes that we'll go through today with a worksheet, and that's what you'll do at home. And then when you're in class with me, we're going to do a lab testing enzymes. The enzyme lab, I think, is one of the neatest labs we do. So I wanted to make sure that we did cover that this year. Okay, so if you take grade 12 chemistry, you're going to see this topic again, except we won't use the word enzyme, we're going to use the word catalyst. And I will tell you the difference between those two terms today. So an enzyme. So our final lesson in the nutrition unit. An enzyme, so it looks like we're biology, but we're going back to chemistry. So even if you didn't take chemistry 30th, back in grade 9 and 10 science, we did learn about chemical reactions. We know that anything on the left-hand side of the arrow is called reactants. Anything on the right-hand side of the arrow is called products. So a chemical reaction, you have reactants becoming products. So in this example here, A, B, C, D, those aren't real elements or compounds, they're just generic terms. We have two reactants and then two different products. So that is a chemical reaction. So what does that have to do with enzymes in our biology class and our nutrition unit? Well, we're going to find out right away. So we're going to learn something called activation energy. Again, if you take grade 12 chemistry, we have entire units on this topic where we go into it a little bit more depth, but we'll just introduce it now in Bio 30th. So activation energy, the definition is the amount of energy needed to initiate a reaction. I love this picture. I think if you see this picture, this describes activation energy and enzymes perfectly. So we look at person A, they've got this rock. If there wasn't a person there, will this rock go over the hill and land here? On its own? No. A rock sitting here will just stay there. But if we push it, if we add some energy to it, and the person pushes the rock, when can they let go of the rock? So they'll have to push it here, 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 but as soon as they get to the top, this person can let go, and then the rock will fall down on its own. So activation energy is the amount of energy this person needs to initiate to put in before the rock will fall down, before the reaction will happen. So from here to the top of the hill, that's the amount of activation energy we need. You have to push the rock, push the rock, push the rock, but once you let go, then the rock falls down on its own. Same thing with a chemical reaction. On its own, if this was our reactant and this was our product, on its own, nothing would happen. But if you could put in some energy, you'd put in some energy, and then once you hit the top of the peak, then the reaction goes on its own. So that's called activation energy. So there's two words, catalyst and enzyme. So let's start with catalyst. In chemistry, we're going to call it a catalyst. The catalyst is the substance that speeds up a reaction by lowering its activation energy. So if I go back to this picture, what does a catalyst do? You'd still have the same reaction, you still have a hill, you still have reactants and products, but what a catalyst will do, it's going to lower the hill. So you're still going to have to put in some energy, but it's less energy. And the less energy you need to put in, the faster the reaction will go. So a catalyst is just going to lower this hill. Yeah, that's it. It lowers the hill. I love that visual. So that's what we mean. It speeds up the reaction by lowering the activation energy. Then the enzyme. Enzymes are a specific type of catalyst. Enzymes are catalysts that are found in living organisms. So in biology, we're going to call them enzymes because everything we study in biology is living organisms. In chemistry, we'll call them catalysts because sometimes we look at living things in chemistry, but most often we don't. So an enzyme is a specific type of catalyst only found in living organisms. So again, this diagram, don't worry about it too much now. If you take grade 12 chemistry, next week or after spring break, the grade 12 chemistry class, they're going to have to learn how to draw this and label all this. So this isn't a full unit in grade 12 biology. But it's basically the person of the picture pushing the rock over the hill. So let's look at the blue graph. The blue graph is the initial reaction. So that's the person with the rock, that's the reactants, that's the bottom of the hill, that's the product. So initially the person has to push the rock, push, push, push. And once they let go, then the reaction happens. So the amount of activation energy is from the reactants, your starting point, to the top of the hill. Now, here, because this is from my chemistry notes, the red graph is the same reaction, but when you use a catalyst, or we'll call it an enzyme since we're in biology. So it's the same reactant, same product, same rock. The only difference is it's a different hill. It's a lower hill. So you still have to push that rock, but now you can let go here, and then the reaction goes. So you have to input, the amount of energy needed to input to make it react, still adding energy, but a lot less. So look at how big the blue arrow is compared to the red. So when you use an enzyme, you can speed up the reaction because you've lowered the activation energy. That's why I think this visual explains it better than the words. Okay, so enzymes, so an enzyme is a specific type of catalyst found in living organisms. So there's different ways. How do they react? It keeps changing. I think the latest one is the induced fit theory. There used to be something called the lock and key. Now we do the induced fit theory. So it's 3 steps. So step 1, the enzymes bind to the reactant. R for reactant, E for enzymes. And then step 2, when they bind together, they actually form something called a transitional state. That star means transitional state. We'll explain that more if you go into grade 12 chemistry. So while they're binding, you've changed the shape of the reactant and the enzyme. It's neither reactant nor enzyme fully. They bind and create this like intermediate transitional state. And then afterwards, the reactants have changed into something called products, but look at the enzyme. The enzyme is unaffected. So the reactants became product, but the enzymes are the same afterwards. So enzymes don't get used up, they're not affected. They basically come in, do their job, leave, and then find another reaction, do the job, and leave. So you only need a small amount of catalyst or small amount of enzyme to make it go faster. So very fascinating. So again, there's a diagram, basically what I just said in words. So this is your enzyme, these are your reactants. So you see initially they're separate, they come together, they change shape, you've got this intermediate transitional state, and then look at afterwards, the enzyme is unaffected. The enzyme is exactly the same from beginning to end, but look what happened to the reactants. The reactants have changed, they now become products. So this picture is exactly what we talked about in the other slide. And that's it for the enzyme notes. So while you're at home today, you do have an enzyme worksheet to fill in. There's some things to answer based on the notes plus the worksheet. And then the next day when you're in class, you'll be with me in the lab and we're going to do an enzyme lab. So our funny joke, you are the substrate to my enzyme and nothing could ever denature us. Ha ha ha. So that ends our nutrition unit. If you look at the notes I've posted, there's still a few more lessons. There's a lessons on vitamins and minerals. I've taken that out this year just for time-wise, but I'll just flip through it quickly because I think you've studied this in phys ed class with nutrition. Plus, a lot of you seem to have a good knowledge about it. A lot of you were talking about minerals when you did your journal reflection at the start of this unit. I don't think anyone talked about vitamins, but you seem to be aware of minerals. So just very quickly, again, this is not part of this won't be on our exam, it won't be on your test, but I'll just quickly go through it because it's still important to know. So a vitamin is an organic compound that's not a carbohydrate, protein, and lipid. So that's what we focused our lessons on. And we can't make it. Your body cannot make vitamins. So you have to make sure you have, you're eating healthy diet so you get your vitamins in your diet. There's 2 groups, water soluble and fat soluble. Again, your body doesn't make it, but you only need them in small amounts. So if you're eating a healthy, properly balanced diet, you should be fine, especially at your age. You don't, synthetics are just like vitamin supplements. So if you're eating a healthy, well-balanced diet, then you shouldn't have to take vitamin supplements. But again, some of you talked about, there's a lot of people that are vegetarians, but you're being smart about being a vegetarian. You're making sure you're still getting your protein and other requirements. But if you're a vegetarian, or maybe there's certain foods some of you said you can't or won't eat, then you need to make sure you're getting those vitamins that maybe certain food groups are providing. So again, just be aware of what you're eating. And then mineral is an inorganic substance. It's not a carbon-based compound. Minerals are inorganic. And again, they're only needed in small amounts, but they do have important jobs in your body. So if we had more time, what I did last year is I would have assigned everyone a certain vitamin or mineral. You would have done some research, made a little poster, presented, but we just don't have time for that. So all I'm going to say is for vitamins and minerals, a lot of you are aware of your nutritional needs and requirements. A lot of you know that you are iron deficient, so you're being aware of that and making sure you're eating some things. Or I know some of you are taking vitamin supplements. You seem to be very aware of the minerals, but again, just eating a healthy, balanced diet, for the most part, you should be getting them in your diet. Okay, and then again, portfolio, and again, diet doesn't mean diet, like going on a diet, fad diet. Diet means your meal plan. Normally, we would have taken some time to analyze that, which we don't have the time to do that, but we did do that journal reflection, so you've actually already done that already at the start of the unit, and I know you've done a lot of work in that phys ed. Okay, so that concludes the notes on the nutrition unit. When you're with me, we'll do the labs, and we'll be ready for our test soon. Okay, good luck with the enzyme worksheet today.